This is Unit 9, Lesson 3. We're talking about division properties of exponents, and your objective is there. Write it down, and let's go ahead and get started. First property we have is called the quotient of powers property. So it's to divide powers having the same base, you subtract the exponents. Okay, so if we have the same base, meaning our base here is a, we're going to end up keeping the base and subtracting the exponents. Again, that's assuming that a is not equal to 0, okay, because we can never divide by 0. For example, if I had 0 to the second power down here, that'd be 0. You can't divide by 0, so a, the base, cannot be 0 for this to work. Alright, so in this case, we've got 3 to the 7th divided by 3 to the 5th. We're going to keep the base and just subtract the exponents. So it's going to be 3 to the second power. Now if they told us to completely simplify it, then we would take that down to 9. If they just said to write it in exponential form, then we wanted to leave it as 3 squared. Alright, same thing here. We got negative 5 to the second divided by negative 5 to the second. So we're going to do negative 5 to the 2 minus 2 power, which is negative 5 to the 0 power. Also known as 1. Okay? Anything to the 0 power is 1. Don't forget that. And it should make sense. We've got something on top divided by the same thing on bottom. We know anything divided by itself is always equal to 1. Okay? But this is how we would write it in exponential form. Let's go on to the next property. This one is called the power of a quotient property. It says to find the power of a quotient, you find the power of the numerator and the power of the denominator, and then divide. Okay, so if I'm going to have two things in here that are being divided, raised to a power, then I raise the top to the power and the bottom to the power, and then use the rule that we just learned. Okay? And again, b in this case cannot equal 0 because the bottom number of a fraction can never equal 0. So if I want to do 2 to the third power squared, 2/3 squared, then I'm going to make this 2 to the second over 3 to the second. Okay? Oops, sorry, it should be 3 to the second power. 2 to the second over 3 to the second. Now if they want it in exponential form, this is my answer right here. If they want this simplified all the way, then it'd be 4/9. Alright, here we got negative 3 divided by y to the third power. You can keep the negative sign with either one. I would normally keep it with the letter, but you cannot keep it with both, because if they were both negatives, then a negative divided by a negative would be a positive. Since we have a negative here, we only apply the negative to one of these. So I'm going to apply it to the 3 here, so we're going to have negative 3 to the third power over y to the third power. The next one, we've got 7/4 to the negative third power. Well, this is a negative exponent, so the very first thing I would do is flip it to the reciprocal and make it a positive exponent like we learned in the last lesson. So the 7/4 is going to flip over and become 4/7. And since we flipped it over, it's going to be to the positive third power. Now we're going to apply this rule, and we're going to get 4 to the third over 7 to the third. Could do this another way. We could apply the rule first and say it's 7 to the negative third power over 4 to the negative third power. But again, our negative rules tell us that if there's a negative exponent, we put it to the other side of a fraction bar and make it a positive exponent. So 7 to the negative third would go to the bottom, and 4 to the negative third would go to the top, and they both become positive exponents. And either way, we should get the same answer. Same thing here. We have a over b to the negative third power. Two ways we can solve it. We can first do the reciprocal and make it b over a all to the positive third power and say that's b to the third over a to the third. Or we can apply this rule first and say it's a to the negative third over b to the negative third. And again, with negative exponents, we have to flip them to the opposite side of the bar and make them positive. So we should get the same thing either way. And we've got one last slide of examples here. Alright, on this top one, we've got our multiplication rules and our division rules kind of mixed together here. This is my personal preference, I like to take care of the multiplying part first, okay, and then do the dividing part. So, how I'm going to tackle this, I'm going to multiply the tops together and multiply the bottoms together, then do any division I can do. Okay, so 2 times 9 is 18. X squared times x is x to the third power. We learned that one from the multiplication rules. And y times y squared is y to the third. I have that over 3 times x times y to the 4th. Okay? Well, now we're going to do any division we can. We can always divide numbers, so we're going to have 18 divided by 3 is 6. And then we're going to have x cubed divided by x, so when we have those, remember we're going to subtract the exponents. So it's going to be x to the 3 minus 1 power, which is squared. Okay? Then we're going to do y to the 3rd divided by y to the 4th. Again, subtract the exponents. So it's going to be y to the 3 minus 4 power, which is negative 1. Now again, we cannot leave anything with negative exponents. We always want to rewrite with positive exponents. So this y is the only thing raised to the negative first power. Okay, so this is like 6 to the 1, x to the 2, y to the negative 1. So 6 to the 1 and x to the 2nd are going to stay where they're at, and then y to the negative first is going to flip to the bottom of a fraction bar, just becoming y to the positive first, or just y. Again, remember, any negative exponents would flip to the bottom side, and I guess I could, since we have a negative exponent involved, put this over 1. Okay, just to show us that this y has to go to the bottom part. And since it's y to the first, we can just leave it as y. So 6x squared over y. Alright, now this one here, we've got a fraction raised to the power. So again, we're going to apply the top to the power and the bottom to the power. Now here's where we got to make sure we don't mess up. Remember, this is like 2 times x. So I'm going to go ahead and just rewrite that over y squared, all to the 4th power. Reason is because if I'm looking at the top, it looks like this, 2 times x to the 4th power. And remember our multiplication rule. Our multiplication rule says that we have to apply the power to each part of these since we're multiplying together. So the top is going to become 2 to the 4th times x to the 4th. And the bottom, we've got y squared to the 4th power. Now remember, when it looks like this is where we multiply the exponents, and we're going to get y to the 8th. So we got 2 to the 4th times x to the 4th over y to the 8th. And since they're all different bases, there's no simplifying that can happen here, and I am done. Okay? I want you to write these in exponential form, unless your book says simplify completely. Okay, if it tells you to completely simplify, then go ahead and take this out and say it's 16. Okay, so you'd have 16x to the 4th over y to the 8th. But I prefer to keep it in exponential form to show me you know how to use the exponent rules. And that's your lesson on dividing of exponents. So good luck on the homework.